Welcome, everybody. Maybe we could start with a song. Would you like that? Yeah. Okay. Let's start with an easy one. Something that hopefully a lot of people know. Okay, that didn't go as well as planned. Okay, this one was better. Thank you. Cool. Let's get back to the presentation. So this talk is called Code, Play, and Rock and Roll. I hope to code some and play some guitar, and hopefully we'll enjoy the show. All right, great. So before we start, a lot of you are guitarists out there, so you are familiar with the scene, but this is what a real pedalboard looks like. These are all tiny gadgets that shape the sounds of famous guitarists, legendary guitarists that we all know out there. And this is how it can look, for example, in software, in one of the tools or products that I've done called pedals.io. This is basically a faithful representation of real-life guitar pedals. You saw two of them in the short demo, and we'll be adding more. An overdrive, a chorus, delay, reverb, and a lot more in the coming minutes. So I'm Arman Amcalar. I come from Berlin. I work for a company called UNU GmbH, and we're building electric scooters, so like Vespa, but with electric batteries. I'm also the founder of Lonja, which is a software craftsmanship school for women. And I like to play a lot with code. I have a lot of open source projects on GitHub that range from brain signal processing to audio processing to front-end libraries and platform as a service and microservices and a lot of other stuff. So what is WebAudio? Anybody familiar with WebAudio? Only a few. Okay. Let this be a call to the guitarists out there. I hope you also write some code. This is extremely fun to play with. This is an amazing playground for especially us, the coder musicians. WebAudio API is basically built into all of the major browsers, and it gives you everything you need to build high-quality audio applications that are like this, pedal boards, or full-fledged digital audio workstations, or game audio in a 3D room where you can adjust the position of the sound, and you can have specific start times and end times for specific samples so that it matches with your animations, your characters. And you can do sound production applications, you can do video production applications, like DJ mixing tools. And basically anything you can do with audio, anything you are used to using on your computers or on your phones or iPads or tablets, they are available through WebAudio API. And you can build any dream application that you have in mind that includes audio, as well as art installation as well, because you can combine it with the input that comes from a camera, and you can basically turn it into sound. You can turn the pixels that the camera captures and portray it as sound samples or any kind of sound effects. If you have ever imagined anything about audio, that's available through WebAudio API. Actually, this was what I had imagined, to be able to play guitar effects free everywhere without the need of installation of a software. And basically, I made it possible with WebAudio API. So a little bit about WebAudio API and its basic structure. WebAudio API is a network of nodes. All you do is you create some nodes, and they are either a source, so that they represent a signal like an MP3 file, for example, or an oscillator like a keyboard, which is a source of sound, or they are sound processing units, sound processing nodes. So these can be, as you see here, like a delay effect that is like an echo that repeats the sound, or a gain effect that improves or amplifies the sound, or some filters, some very wonky filters that I will demo in a couple of minutes that you can do. And of course, at the end, there's a target, a destination, an output, which is your headphones or your speakers, whatever you like. Or it could be a recording target so that you could save whatever you created with WebAudio to an MP3 file, much like rendering in a digital audio workstation. The idea is very simple. You create these nodes, and you set some parameters, which is very, very simple, extremely simple. You don't have to know a lot of math. Actually, you don't even have to know math for anything except one special node that is kind of there to introduce gain distortion effects. But then you connect them. You connect them together, starting from the source, from the guitar, or of course that's a guitar for me, but whatever source of input you want, maybe it's a mic or another audio file, and you connect them in whatever way you like, and then to the output, and everything happens in real time. Okay, so WebAudio hosts a lot of components that you can generate, that you can create. It starts with an audio context. Everything has to happen within an audio context. Anybody familiar with Canvas API? To draw some pixels? It also has a context. So in order to draw something to the screen, you have to get a hold of a context. And audio context is basically the same. In order to do any audio application, you need to have an audio context. Now, you can have more than one, and you can connect anything to more than one context to have multiple plugins or other applications. But in the end, you need at least one audio context. Then there's the offline audio context for you to be able to record something again. And a lot of processing nodes, processing units, like, again, gain, delay, panner, convolver. Panner is used to direct the sound to either left or right channels. convolver is used to introduce effects like the echo effect here, the hall effect, like a cave. You know, your sound kind of echoes and drifts away in a cave. Those effects are made by finite impulse response filters, and a convolver node is basically used there. And you can have an analyzer node, so you can actually grab the signal and look at its properties. So look at the frequency content, look at the power, and you can do various effects based on that. You can split them into multiple channels, multiple tracks, so that the graph can get wider and wider as you want. It has a lot of nodes, and lately they also introduced some audio worker. So it's like a service worker. It works in the background. It has separate threads, and basically it allows you to implement your own algorithms, your own scripts or functions that will run per sample, but it will run off thread, and so you won't hit a performance penalty. So you won't be using the main thread of the browser, but it's parallel so that you can have multiple of them, which makes the browser a very nice competitor for digital audio workstations. Like, you can really get real production grade audio applications right inside the browser. And okay, here's a very small example. You start by creating a context, which you do new audio context. And as I said, everything is hosted under that context. So you can create a gain node, which will amplify the incoming signal by doing context.createGain. And you can connect it to the destination, which is the speaker output, or whatever you like again. Here's another example to basically load an MP3 file and use it as the source. You can create a buffer source and load the buffer that you downloaded from the internet, and use it, connect it to the gain as the input. So this basically gives you a graph where the source is at the beginning, in the middle you have the gain, and in the end you have the destination. But this is basically as simple as this, loading an MP3 file. Okay, let's talk about Pedalboard.js. It is the first open source WebAudio framework, I guess. I did it in 2012. Back then, WebAudio API wasn't a thing. They were still developing it. It didn't have stream input, for example. It couldn't capture directly from your sound card, and could only work with static buffers. But those days are fortunately behind us. And 6 years later, it's still one of the best guitar effects library out there. Full disclosure, I wrote it. And it's GPL licensed, and it has a very nice documentation, both inside the source code and as a README. And it has very nice abstractions based on the guitar world. So if you are into building your own pedals, which I am, you can build your own pedals here very easily and make it a part of the library, or play with it however you like. Anybody doing guitar electronics, like their own pedals? Nobody? Okay, interesting. Good. Some of the guitarists should start doing that as well. That's very fun. I started by doing real electronic circuits for overdrive pedals, and then moved on to the digital world because this is a lot easier. So you have pedal boxes, pots, potentiometers, knobs that you can twist and turn around, switches that you can push, and LEDs that blink. And basically you bring these together to make pedals. This is built on top of something called Google Closure Library, which is ancient by today's standards. I guess started in 2008 or something. Anybody using Google Closure Library? One person, you're my hero. Anybody who has used it before? Another person. Well, it's arguably the best user interface library out there. It's by Google, and it's what Gmail, Google Docs, and all the other serious Google tools are built upon. It has an amazing compiler, like nothing the other guys can do nowadays, like even Rollup, or I don't even mention Webpack. But yeah, Google Closure Compiler has a really nice mode called Advanced Mode, which rewrites your code from scratch, doing a lot of optimizations, just like a real compiler, just like a C compiler. And it also optimizes for speed and for download speed and for runtime performance. So Pedalboard JS is built on top of Google Closure Library because that was the best choice in 2012. But I guess I want to rewrite it now with ES6. So if anybody out there want to give a hand, that will be appreciated. And it uses something called an MVVM architecture, which is kind of out of fashion right now in the front-end world. But yeah, so you have a stage. As the audio context in WebAudio, in Pedalboard JS, everything starts with a stage, as you see here, because without a stage, there's no musicians. Even if you're playing in your bedroom, that's your stage. And then you have a board, a pedal board, that hosts your pedals. And you have some boxes. Initially, they are empty, so it's like a GOT class. But you can fill them and make them guitar pedals. For example, a reverb or a delay pedal is a box with some inner circuitry. You have a foot switch that can toggle on and off. LED spots, again, file inputs. And maybe the most important one is the stream input, which is the thing you use to capture the sound of your guitar or a live instrument, or also a microphone. So you can actually do pretty fun effects with your voice just in your browser. Okay, I'm not going to go into the details here. I'm going to show you some code. But before that, I also want to talk about Web MIDI API. Now, anybody, again, please raise your hands if you have played with the Web MIDI API. 1, 2, 3. Okay, this is also another very, very fun API that opens the web to a world of immense possibilities. You can do anything with it. So you can grab any DJ gear, any musician gear, like a keyboard or a drum pad, or I don't know, something like this. So this is also a MIDI controller. It's a wireless Bluetooth MIDI controller. This thing is for the foot pedal, but there's a Bluetooth connection to the computer. So basically, you can connect this to the browser directly and get some messages from that. Depending on which key you press or which button you press, you get a different message on your browser, which means you can then do whatever you want with it. You can use it for, I don't know, scrolling pages, or hiding ads, or, I don't know, photo applications like photo filters. For me, for example, I'm really sick of editing tiny sliders on my phone when I edit photos, or like in the computer, even worse, with a mouse, you have to click something to change the brightness of an image, for example. But if you have a MIDI controller that has a knob that you can turn, it's a lot simpler to modify images or sound if you're a DJ. Basically, the mixer that you see before the musicians, they are also MIDI controllers, and they can be reflected right in the browser, and it's super easy to get started. So also these gears are like, they start from, I don't know, $20 or something. So you can get extremely cheap MIDI gear and use it as an external input device to the browser, because with a mouse you can only do so much, but tactile input is really good. If you have a pad or a slider, a fader, or a knob that you can twist to, I don't know, to turn on the volume of YouTube videos or something, it's really, really effective. And of course, you can also do some games with it. Let me see. Oh yeah, here it is. So this is a snake game that I implemented in one of the DJ gears. The one on the left is the real DJ pad. The right is the browser. So I basically mirrored it in the DOM. So that's a snake game that I play with a real DJ device. So you can turn on the lights on and off through the browser, and again, it's connected over Bluetooth. And yeah, you can do a lot of stuff with it. Cool. So how does it look like? Really, it's extremely simple. Again, you do navigator.request MIDI access. So I want some MIDI devices to be available. And it gives you something with inputs and outputs. So what you do is you traverse over the inputs and attach an event handler called MIDI message event handler or whatever. So basically, there you get an event every time something changes in the MIDI device. Like when you press a button or when you turn a knob or anything, you get an event that is not that significant except for the data, which is an array of 3 values, or sometimes even 2 values. And they are the numbers, the channel that the middle signal is coming in, the note, the control change or program change signals, and its value. It's either 0 or any value up to 127. It's very simple. And then you do whatever you want with it. And of course, as you can imagine, what I did with that is I connected it to my pedal board, and I can turn on and off my pedals in real time as I play, because I don't have a third hand yet. So here's the demo. That is the patch that I was using. First, I actually want to show you how the yeah. So if you see it there, the LED is blinking. It's turning off and on. And I can also turn on and off the second one. If I long press this, it will change the patch. So it will go to the second song so that I can play that one. And yeah, I can turn on and off different pedals. And the other one has a very nice pedal called the wah pedal. Anybody familiar with the wah pedal? Wah pedal? Good. Well, there were more guitarists here. You should learn the wah pedal. Okay, so basically it's like this device. This is called a pedal. It's a very confusing name. Everything apparently is called a pedal, but this is also called a pedal. You can step on it, and as you see, you can step on it to change the value. And look at the second one. I hope you can see it. The effect knob changes as I move my pedal, which means it opens the wah pedal or closes the wah pedal depending on the position. So basically, I use these with my library to make some music. Okay. Now let's see some code. Cool. So, is it readable from the back? That's nice. Thank you. So again, it's very, very simple. I included Pedalboard.js as a global library. So even though this is a module, some of the components are available in the global context in the window. So I call something called a stage. It has its own context. So stage creates its own audio context. And that is what you use to create your other pedals. So you create a stage. You create a board, a pedal board. You use the stream input to get the guitar. And you set the board to the stage. And then you have some pedals. Let's see. So you have 3 pedals out there. Yeah, the first one is a noise gate. A noise gate basically saves your ears, because when you use distortion or overdrive, there is a lot of hum and a lot of noise that I'm going to demo right now. That's really, that's not ideal. So you use a noise gate to block those noises, but it has a switch that you can toggle on and off. Or you can change some of its values. You won't see it there, but there's a threshold pot here, and you can change it, and it is dynamically reflected in the value. So you can play it here with your mouse, or, as I hate mouses, you can change it through code or through this pedal. So let me try another one. Cool. That's it. Thank you. So basically, this is Pedalboard JS, and this is what you can do with the browser. Only a fraction of it. So I encourage you to take a look into both Pedalboard JS and the WebAudio API. Thank you again.